students. In continuation of our Laplace transformation on the various results, let me start with after seeing the basic definitions in the Laplace transformation. Next, we shall go to the properties of Laplace transformation. Before going to apply the properties on each Laplace transformation function, let me remind that you need to practice all the properties in the Laplace transformation basic. Then only you can come to the properties of Laplace transformation. The first one among them is property number 1. If L of f of t is equal to f of s, this is the given function, then property will be L of e to the power at into f of t. What is the meaning of these two products? Here f of t is the given function. I mean f of t may be either a constant or a sine or cosine or e to the power at or sine hyperbolic at or cos hyperbolic at. But the first function e to the power at is always constant, fixed, it will not change. Then the product of L of e to the power at into f of t will be f of s minus a. F of s minus a. How to get the property? How to apply the property on Laplace transformation? The question there is here. Whatever be the derivation given here, come to the condition. L of e to the power at into f of t is equal to what? F of s minus a. What we have shown here. Let me explain the thing. How to apply the property on the product of these two functions. What is the first condition? L of f of t is equal to f of s. Out of these two products, choose f of t. What is f of t? It is a coefficient of e to the power at. Other than e to the power at, choose that function as f of t. Okay? You are getting my point? Then find its Laplace transformation. L of f of t, as we are shown here. L of f of t is equal to f of s. Then f of s. Then what is a here? Coefficient of t under exponential. Coefficient of t under exponential. Then the ultimate result will be f of s minus a. How to get the solution here? Let me to repeat it. First of all, find f of t. What is f of t? Coefficient of e to the power at. Then find Laplace of L of f of t. It will be in terms of f of s. I mean s in terms of s. Take the a, coefficient of t under exponential. That is the first function under this product. Then replace s by s minus a. Replace s by s minus a. That's all. Let me take the second one. If L of e to the power minus at into f of t, what is the condition? If it is e to the power at, f of s minus a. If it is e to the power minus at, f of s plus a. You are getting my point? Therefore, let me repeat the things once again. First of all, find the L of f of t. It will be f of s. F of s means what? Suppose L of k is equal to what? A upon s. What is L of sin at? It will be a upon s square plus a square like this. Then find the value of a. And that a will be coefficient of t under exponential. Then replace s by s minus a. Replace s by s minus a. And this property is known as first shifting property under the Laplace transformation. Okay, come to the second property. If L of f of t is equal to f of s, if L of f of t is equal to f of s, then L of t to the power n into f of t is equal to minus 1 to the power n dn upon dsn f of s. What is the difference between these two? Here L of e to the power at f of t, here t to the power n f of t. What is the nature of e to the power at? An exponential. What is the nature of t to the power n? An algebraic. Again the same procedure we need to adopt. What shall we do? Find L of f of t, that is the coefficient of t to the power n. Okay, and it will be what? F of s, whatever it may be. Then power of t. What is the power of t? This is n, right here, minus 1 to the power n. dn upon dsn. What is the dn upon dsn? This is the nth derivative of the given function, I mean f of s. F of s is already taken. L of f of t is equal to f of s. Put f of s here. Depend upon the value of n. Suppose if it is t square, what shall we do? minus 1 square d square upon ds square of f of s. What is d square upon ds square? Second derivative of f of s with respect to s. Then minus 1 to the power 2 will be plus 1. Similarly, if n is equal to 1, n is equal to 2, n is equal to 3, we can go for any number of n. Provided it should be coefficient of n will be always positive. N will be always positive. This is the second shifting property. Come to the next one. If L of f of t is equal to f of s, then f of t upon t. What is the difference between these two? Here t to the power n present in the numerator, here t present in the denominator. If f of t is divided by t, I mean the quotient of two functions. What is the condition? Again find L of f of t, put under integration, integration between 0 to infinity, get the integration of that function with respect to s. You have got my point. Suppose if f of t is equal to sine t, if it is sine t upon t, what shall we do? Find L of sine t. Okay, what is sine of t? A upon s square plus a square. Then integration between 0 to infinity. This is fixed. I mean the limits are fixed for any integral. This is the third property in this case. Yes, I am writing all the properties once again. My dear students, please make a chart of all these results, include these results in the basic properties. Then let me take one simple example. Find the Laplace transformation of e to the power minus 3t into 2 cos phi ut minus sin phi ut. 2 cos phi ut minus sin phi ut. Then we have f of t is equal to 2 cos phi ut sin phi ut. Then what shall we do? E to the power minus 3t is common, keep it outside, then find f of t. F of t is what? Its product term. Then f of t will be 2 cos phi ut minus sin phi ut. Take its Laplace. Take its Laplace. What is cos at? S upon a square plus a square. What is sin at? A upon a square plus a square, where a is equal to 5 in both cases. Just observe here. You can take the results from the basic properties of the Laplace transformation. Take the LCM between them. Then apply the Laplace transformation. What shall we do? Take the coefficient of t under exponential. This is what? F of s. Yes, put f of s here. What shall we do? Take value of a under coefficient of t under exponential. What is the value of a? Minus 3. Therefore, what shall we do? S is replaced by, actually it is s plus 2, not s plus 3. It is s plus 2. It is e to the power minus 2t. Please make a correction here. Therefore, s is replaced by s plus 2. This in this function. Go for simplification. This will be our one of the result for the Laplace transformation. My dear students, before going to apply the conditions, I mean the properties, I mean the example, please try to know these properties at a glance. First one, second one, and third one. Okay, thank you.